Warning: tube amplifiers have lethal voltages inside them. Please do not attempt to build, test, or repair these without understanding and following all safety protocols. Hey y'all! Well, we're back for another session of building on our simple push-pull amp. And no use in wasting a lot of time. Let's get busy building. So the next thing we need to do is wire up the 6.3 volt heaters on all of these small tubes in the front, the output tubes in the input tube phase splitter, and they're going to come over here to these two pins right here, and this will, once we get that hooked up, then we'll finish wiring up the voltage divider and stuff. So first we want to get the heater wires run over to the tubes, and this is a really important part of the amplifier to get right. There's a lot of current going through these wires, low voltage AC. We also want to keep them over in the corners of the chassis, which helps null out the AC hum. And as you can see, they're also twisted. And I made these up off camera. They take a little while, and to me this is one of the more fun kind of artistic parts of the amp that really looks cool, is these heater wires. And so I'm going to zoom in here and show you on this 12A T7 tube, because it's got a kind of unique wiring. Pins 4 and 5 are tied together, and then the other heater wire is over here, pin 9. And they're made this way so that if you were running a 12 volt power supply, you would go across 4 and 5. But if you're going to use a 6.3, you tie these two together and then you hook the other wire to pin 9. So, because it's the center tap of the heaters. And then as you can see, I've run it across the top of the tube, keeping it away from these other pins as much as possible. So we're going to come in here, the first thing, and solder this end. And I always start at the farthest end in the chain when I start soldering up my heater wires. So we get a nice clean tip, freshly tinned. We come in here, and I like soldering this little junction here where we have two pins and the wire as my first solder joint. And come over here, and there's the other side. So then we have our next wire that goes from one output tube to the other. Like I said, they're just daisy chained across each other until you get over to the heater tag strip. Now, that's probably going to stay there. We need to be ready to, yep, see, it's going to try to jump out. I might put something with a little bit of weight to kind of hold that in place. So we'll get the most hated tool on the channel, my ancient little channel locks, and use that to hold this in place while I solder this all together. Like that. And then solder this other one up. Just like that. So then we come down to our other output tube, and we have this final little stretch of our heater wire. We come in here, solder this one up. And the thing to remember when you're doing this, we're doing this as a hobby. So take your time and just, enjoy the process. Don't be in a big hurry. We're not trying to, do production and see how many of these we can knock out in an hour. We're trying to make something really nice. And so just enjoy yourself and take your time and do like I'm doing and make it really pretty. So then we're going to come in here and solder up this last joint, but I'm not going to fill up this hole this whole tag strip hole. I'm just going to kind of tack it down at the bottom because we've still got some more components to add to these terminals. But I don't want the wire going anywhere. Just like that. And now we have our heater wiring all done, which I think it turned out super neat. And again, it's away from the signals, the transformers, the tag strips for these tubes are going to be like here, here, and here. So they're going to be, the capacitors and resistors and everything are going to be away from the 6.3 volt AC wiring. And this is our other 110 volt AC wiring that's over here too. Also, over here on this side, kind of in the corners and away from all the signal wiring that's going to be in the center part of the amp. And it's the way I've been doing this on all of my amps, and I've had no problems with running AC heaters. I hear people saying, "Oh, you gotta use DC for the heaters." You really don't. Unless it's a preamp, a regular amplifier is fine running DC heaters. I guess the only thing that you need to be careful with if you're using a direct heated triode, but all these are indirectly heated tubes, and so that's not really an issue. So the next thing we're going to do is get the parts together and finish up wiring this voltage divider, and then we're going to power this thing up and check all of our voltages. Okay, the next thing we need to do is we need to create our virtual center tap for this voltage divider that's going to apply 50 volts DC on top of the 6.3 volts AC so that we don't have too high a voltage differential between the cathode of the tube and the heater of the tube. The maximum that can be is 100 volts, and on the phase splitter the cathode is going to be sitting at 115 volts, which would exceed that specification. So we need to come up with 50 volts DC to put on the center tap of the heater, and since the transformer doesn't have a center tap, we create a virtual center tap with a couple of 100 ohm resistors. And I'll show you in a schematic, but that's what we're going to solder in right here. And we're going to start with this first 100 ohm resistor, and we're going to solder, let me clean my tip, and we're going to solder this into this first. That, we'll clip this excess lead off. Like that. Then we have our second resistor here, which we've put some of our PTFE tubing on. Let me get my hands out of the way here and you'll be able to see that. And then this resistor goes over from the center point to one side of the heater, and then this resistor goes from the center point to the other side of the heater. And this is gonna, it was worth that fight earlier to be able to make this part of the build a lot neater than it was on the other. Actually, let me go ahead and solder this in first so this resistor doesn't jump around on us. Just like that. solder up these two resistors to this tag. And there we go. Cut that excess off of this one. And bend that resistor up so that looks nice and neat. And I haven't talked about this lately, but these are some fantastic little flush side cutters. They're made by Heiko, and Amazon has them, but they're at a really reasonable price. And then they have a matching stripper that's also super high quality, that's very reasonable. And I'll put a link in the description for these two tools. If you don't have a really nice set of cutters and strippers, you should pick up a pair of those. They're really handy. So the last thing we're going to hook up is this little jumper wire here that goes across from the first one side of the voltage divider over to our high voltage DC. And let me come in here and see if I can crimp this so it'll stay in place while we solder the other side. And for now, mainly I just want to get it tacked up here. And I'll come back and final solder where I fill the whole hole in. I know that isn't necessary, but I think it just looks better when these tag strips have the hole completely filled in with solder. Sometimes that's a little tricky when you're fighting gravity, and I've learned times you have to stand the amp up on its end or on its side so that you're not fighting against gravity while you're trying to fill those large holes up in these tag strips. And this one's already been filled up, so I really just need to get the solder wet and put the wire through, and then come back and make sure we get a really good solder joint here. Then we'll come back and fill in this tag strip hole. And then lastly, this last tag strip tag down here isn't filled in either, so let's do that. And that completes our power supply. We're ready to put this thing on the Variac with the isolation transformer and check out the voltages from the transformer and make sure we've got the correct voltages in all these pins and that these heater voltages look reasonable. And then we'll put our rectifier tube in and slowly pull it up on a Variac, making sure we don't exceed our filter capacitors. And the other thing to note with this circuit design, this voltage divider that we have over here for the heater DC offset also acts as our bleeder resistor for this amplifier. And so we have 180K of resistance going from positive to ground that will bleed down these capacitors after we turn the power off. So there's no point in adding in a separate second bleeder resistor. So let's get this thing ready to put on a Variac and check some voltages. Well, I went to power up the amp and I was getting nothing. And I was going, what in the world is going on? And I made a mistake wiring up this power switch. I was looking at the mirror copy of it and looking at it that way, I ended up hooking up these two wires to the, one of these is hooked to the normally open contact, one of these is hooked to the normally closed contact, and then the main feed one for the switch isn't hooked to anything. So I need to unsolder these two wires, spin this switch around, and solder these two back up, but to this pin and that pin. So no big deal, and I found that by coming in here with my meter and probed in this white wire had line voltage on it. But when I go back and forth with the switch, this one was never changing to anything. And then when I put the probe on this one, when I would push the switch in, this one got powered up. And then when I started reading the note letters on these, I realized what I'd done. So let me get that straightened out, and then we'll check these voltages. Okay, here we go. We've got our setup hooked up with our variac, hooked up to our isolation transformer, then to the amplifier. We got our switch wired right now, and let's pull up some voltage here. We're going to check our 6.3 voltage first, and that should be about 120 volts marked on my variac, which I've calibrated, and 6.7 volts sounds about right for an unloaded 6.3 volt rail. So let's turn this back down. Let's go over here to our 5 volt. Connection on our rectifier tube. And let's power this guy up. And 5.3 volts sounds about right for an unloaded 5 volt winding. Again, these transformers, when they're unloaded, the voltage is going to be higher than once you get them loaded up. So, last thing we want to come in here and check is our high voltage AC on the rectifier tube. Again, with no rectifier tube in it, we have no DC voltage. So the capacitors, nothing's getting charged up. We're just measuring the AC voltage coming out of the transformer. So here we go with the high voltage windings. And we are getting high voltage. We should see 600 volts. And that's it. 120 in, and we got almost 630. Unloaded, that sounds about right. So we're ready to pop a rectifier tube in this thing and see what kind of DC voltage we get, make sure all that's working, and then we're going to check our voltage divider over here. Again, at this point, we don't have the rectifier tube in, and so there's no DC voltage. None of these capacitors are seeing any voltage, so nothing's getting charged up. So let me go grab the rectifier tube, and let me go ahead and hook these probes up to our DC. Switch that to DC, and let me pop the rectifier tube in it. Okay, here we go. Let's see what kind of DC voltage we get. I'm going to set it on about 80 volts here. And I'm not sure how far past our rated voltage we're going to see with an unloaded rectifier. So remember, with a tube rectifier, we have quite a bit of voltage drop across, especially this type of rectifier tube. And so you don't want to like just pop 120 volts on it, because it can go way past what we want to be seeing. And let's go ahead and see what it is when we turn it up to 120 volts. So that's the highest this would ever see, which is an unloaded rectifier tube, and we're at 420, a little over 425 volts, which is within the specs of our filter capacitors. That's why we're using 450 volt caps, even though we're only going to be running about 330 volts on the actual amplifier at the plates. Actually, let's turn this off and see how long these bleeder resistors that I was talking about, that are the voltage divider, take for bring the voltage down where it's a safe level to mess with it. Now remember, when the other tubes are in the amp, they draw current even after you turn it off, and so this voltage will come down a lot quicker. But without that voltage divider that's creating a bleeder resistor circuit, this thing would just sit there at 430 volts, potentially for hours. And that's why tube amps can be so dangerous even after you turn them off. And like, even with this bleeder in here, you wouldn't want to stick your finger in there right now with over 100 volts of DC voltage on these caps. It'd definitely give you a nasty shock. So we're going to let this thing get down below 20 volts and then do our last voltage check, which is going to be the center point of this voltage divider for the 6.3 volt heaters, and make sure that we've got around 50 volts there. And once we get that done, the power supply will be finished, tested, and we can move on to wiring up the rest of the amplifier. Okay, the voltage is low enough, so we came in here, we moved these probes over, and this is on the center of the voltage divider, and that's the ground. So let's power this thing back up. Again, we'll start on around 80 volts. It was about 85 volts input where we were seeing 330 volts on the DC. And we got 54 volts on the voltage divider, which is perfect. I mean, anywhere from 45 to 60 volts would work fine for what we're trying to do. So 54 volts is definitely within that range. Voltage divider's working. We're ready to wire up the rest of the amp now that we know that the power supply is working like it's supposed to. Okay, so now that we got the power supply tested, we're going to work on installing the rest of these tag strips. And so we're going to have one placed right here in the middle, and it's going to have a capacitor and a resistor that's the decoupling network for the driver tube and the phase splitter. And it's going to have a wire that comes up off this high voltage DC. It's going to run up here. We're also going to need a ground wire. So it's going to come off here, go over to our star ground point. Same thing here. A tag strip that says like that. It's going to have a ground wire, comes over, goes to our star ground point. Same thing with this output tube. It's going to have a tag strip here for it. You have another tag strip here for it. So the next thing we need to do then is start cutting up some wires that are going to be used for our ground leads that come over to our star ground point. And you just kind of start laying them out. Like, we know that guy's going to go like that. Kind of like that. Let's go ahead and strip that off. And one of the things I've learned is trying to solder to these tag strips when they're bolted down is almost impossible because all the heat transfers through this lug to the chassis. So you need to solder these, especially if you're going to be soldering into the lower pins or these lower holes. You need to do that before you bolt these things down. So we're going to go ahead and kind of get these where we think they're going to be. And that one's going to be almost straight back. And we're probably going to go ahead and solder them all to these tag strips and then bolt them down. And then run the other end of the wire, strip them, and then solder them to the star ground point and get all of our grounds established. Now, there's been a little controversy, people thinking that, I shouldn't be bolting these down to the chassis and should have insulated grounds. And I've been doing this on every amplifier that I've built so far, and I saw Mark at Blue Glow talking about this, and he's doing the same thing and never had any problem. As long as you run a copper ground wire from the ground terminal on the tag strip to the star ground point. And I believe that the current is going to follow the path of least resistance, which is going to be the wire. And as you can see, I'm not scraping the powder coating off or trying to get a good connection at all to the chassis. And I'm relying on this wire to be conducting the majority of the current. So then we have this one over here. And this one's going to be probably the most convoluted path. It's going to be this one. And we're adding a little extra wire just to make sure we don't have them too short and we get them all bolted down and then go, it won't reach. We don't want that to happen. And then the last one is going to be this one right here. And it's going to come out kind of like that, turn 90 degrees. Come over there. And strip this one off. Like that. So now we have, let me strip this one off. We have a ground wire for each one of these tag strips to run over to the star ground point. And let me get my soldering iron heated up. And I think here we'll maybe use my little copper guy here, or my little alligator clip guy, and see if we can make this work for holding that and then holding the wire in place while we solder that into the tag strip. I think that's going to work perfect. Let's put these over here so it's a little less confusing looking while I'm soldering these up. And come in here and solder that ground wire on. Now that I'm doing this, this would have really worked better than what I was trying to do when I was fighting with those heater wires over here, soldering them to this tag strip. If I'd used this alligator clip like this, that would have made that not frustrating at all. So, not only are y'all learning, I'm learning too. So there's that one. There's that one. And then here's our last one. There we go. So let me get these tag strips all bolted down, and we'll come back and prep the ends of this, solder that in there, and that's probably a good stopping point for this video. Okay, so we got our tag strips all bolted down, and where we got the ground wires run off this center terminal. Again, it is bolted to the chassis, but the real ground path is through each of these wires to the star ground point. So I'm going to solder this group of wires here to this terminal here. Then we have all of our tag strips installed and grounded, and we can get started on wiring up the rest of the amplifier. And I'm going to set this lens right there, put a little weight on these wires to hold them in the right position for soldering this all together. And there we go. And like I said, I think this is a good place right here to stop this video and continue on to the next one. Well, as you can see, we got a lot done this episode. We still got some, other sections of the amp to deal with. I think one more video will probably wrap up this build series. And I know this is kind of a slower step-by-step video that some of you guys that are more experienced really don't have a lot of interest in watching me do it this slowly, but some of you maybe do and just enjoy watching this. So I think especially for new folks, this is a really good format to kind of show them, and hopefully y'all picked up a few little tricks along the way as I'm showing you some of my techniques that, every time I build one of these, I discover another way of making things easier to do it. So I hope y'all are learning stuff too. If you're enjoying my channel, please subscribe to the video. We're over 5K subs, which is awesome. And please like the video. And we'll see you soon. Have a nice day.